Welcome back to the lecture series on air pollution, fundamentals of air pollution, sources, effects and mitigation. In the previous lectures we discussed about the dry and wet deposition of the aerosols, air pollutants, and how to calculate them. Then we also discussed that deposition of the aerosols, because they contain several micro as well as micronutrients, they can directly impact the ocean biogeochemistry. And then we discussed about ocean acidification and then impact on the biogeochemistry, how as well as that how the ocean acidification is going to affect the corals, reef, and then other foraminifera and other calciferous organisms. So, this was in the previous lectures that we discussed. Now, in this lecture we are going to discuss something very important on the cryosphere, for example air pollution and cryosphere. So, in the first I will discuss give the brief about the cryosphere and then where it is there. So, if you see this one, this is a very important slides. If you have to understand, the water exists in the form of either solid, in the form of ice, or it is in the form of liquid, which we mostly use, or in the form of gas, which is actually in the form of vapor, atmospheric vapor. So, if you just see, so cryosphere is actually a place where the ice or the water is stored in the form of solid or in the form of ice. So, this is the cryosphere. And before we start, this is very important that about, if you take 100% of the water that is available on earth's surface, about 97% of the water is actually in the ocean. So, only 3%, and this ocean water is actually mostly saline. So, this water is not directly useful. So, we cannot directly use these waters. So, what is important here, that we have to this is the usable water that we actually use. This is actually usable water that is available on the earth's surface, is in the form of fresh water, which is only 3%. So, you can imagine just that importance of the water. Water is there actually on the earth's surface, but much of the water is actually, most of the water in fact you can say, as 97% of the water is in the ocean, and we know that ocean is actually saline water. It directly cannot be used for in fact any purposes. Neither you can drink, not you can put it for the agriculture, not in the industrial process. So, this becomes that our livelihood depends on mostly on the fresh waters. Now, if you just decompose, this is actually, it is distribution. You can just see sometimes numbers are little bit complicated. In the next you see it is actually written that it is 97.5%, and so if you take 97%, this will be only 2.5%. This is more kind of correct estimates. And if you see, out of those 2.5%, which is actually this water, that is only 2.5%, about, which is fresh water, 1.6 is locked away either in the form of glaciers or ice caps, and out of 1.6% is locked either in the form of glacier or ice caps or in the groundwater. So, if you just see this one, there is actually 1.67% or 68%, 68 into 1.6%, it will be actually like 16.96, about 1.1 or 1.2 actually you can say. This much out of this 1.6, almost like 1.1, 1.2% is actually locked as glaciers and ice waters, and groundwater is actually 30%. So, this means 1.6 into, so this means about 0.48% of total water. You have to remember here it is of total water. So, if you take water as 100%, so this means only 0.4% 0.48% is actually available as a groundwater. And then you just take about this one, out of those 100%, 1.2% is almost like locked in the form of 1.12 or 1.2. You have to just calculate the numbers. If you just subtract from here 0.48, it will be like 1.12. So 1.12% is locked in the either in the form of glaciers or in the form of ice. Now you see the remaining. So 68.7 here and 30%. So remaining it's only actually and if you just see this one 1.6. So out of 2.6, 2.5% that was actually fresh water. 0.9% water is actually directly accessible to the humans. So see the problem here. Water is there, water everywhere, but it is not directly accessible to humans. And if you talk about these numbers, about this 0.9%, okay, which we calculated here, of 100%, okay, of total water. Just remember these numbers, because whenever you are saying the percentage, you have to always talk about denominator, because denominator becomes very important. So with respect to 100% availability of the water, about only 0.1%, even not 1%, is available or directly accessible to the humans. If you just see this one 0.9%, there is a distribution like out of 0.9%, soil is having about 4%, swamp and marshes they have about 2.6%, biological water is about 0.3%, lakes has almost like 20.9% of this actually. So okay, 0.9%, and groundwater is actually, and snow, groundwater and snow is actually 60 or 70%, 69% to 75%. Atmospheric water, that I gave the example in the initial slides about the liquid, this one atmospheric water, the atmospheric vapor is about 3%, 3% of 0.9%. Okay, so this is becomes very minimal amount of if you compare this one, and river water is further less, about 0.44%. So you can imagine a situation that the distribution of the water is very important, and if you see the distribution of the water, the role of this 1.6% of locked, which is locked away, and then about 1.12% of the glaciers and snow, they are very important when we talk about the global climate cycles, because they really reflect this radiation. So we will come to this one in the feedback mechanism. So snow usually is highly reflective surfaces. So if anyway, if you just are going to reduce, or if the ice, glaciers and ice caps are lost, and they are actually in the form of water, liquid water, they are actually like either they will go to the ocean or somewhere else, or groundwater, but they will mostly go to first ocean, then they can be distributed else. So if they are lost, the reflectivity or albedo of the earth's surface will reduce. So this is very important. So what is cryosphere? Cryosphere is actually like refers to the parts of the earth's surface where water is in the solid form. So this includes snow, ice, okay, and then you have a glaciers, and then you have a frozen ground, okay. So it is in the thermofrost we call it actually, okay. So either it could be snow, ice, glaciers, or frozen ground. So all the forms including, they are actually they are together referred as actually cryosphere, and this cryosphere is actually very important. It is very important, and it is an integral part of the global climate system. So we will see that how the climate can be controlled by this one, because if you just remember in the some of the previous slides, I talked about the albedo. So albedo was actually some of the what you call alpha ice, some of the albedos from different kind of components that are the earth's surface has, and among those components, snow and this one cryosphere, they actually are highly reflective. Okay, so they are highly reflective. This means they have highest albedo, highest alpha. So if somehow or other you are losing this cryosphere or snow, then your albedo is going to be disturbed, and when the albedo is going to be disturbed, what will happen? The outgoing radiation will reduce, so it will cause to the global warming. So this is actually very well known. This modulates surface energy, as I talked about. Moisture flux, clouds is also affect the clouds, precipitation, hydrology, and atmospheric and ocean circulation. So this is very important. So you can almost see now what are the components that can be affected by the just presence of the cryosphere. Is actually it will modulate the surface energy, moisture flux, cloud, precipitation, hydrology, and atmospheric as well as ocean circulation. So this is really very important component, but this is of course is very less studied in India. Variability of the cryosphere has broad ranging socio-economic impacts, including land and sea transportation, water resources, sea level changes, wildlife, and recreation. So if there is a change in the composition or the actually even the availability of the or the percentage of the cryosphere, then it will directly impact whether it is in the land and sea transport. It will affect both. Water resources will be severely affected, sea level changes can actually be seen with this one, wildlife will be affected, and then recreations. Okay. So the cryosphere theme is established by the International Integrated Global Observing System partners in. So this is also very important. So in 2004, integrated global observing strategy were planned. Actually, these partners were planned. So they were actually monitoring these things in 2004. So as I said that if you just see the component of the cryosphere, so we have the first one is actually snow. Snow is actually temporary ice cover on the land, and this reflects sunlight, maintain Earth's energy balance. So this is very important. Snow is although is lesser part, but it is actually very important. It's actually temporary. Although it is temporary, it reflects the sunlight and thus maintains the Earth's energy balance. Then you have sea ice. This is actually the frozen sea water found in the Arctic and Antarctic regions, and this reduces atmospheric ocean heat exchange. This is very important and supports unique ecosystem that is there actually. So because of this one, if there is a disturbances in the aerial coverage of Arctic or Antarctic, there will be a reduced ocean atmospheric heat exchange, and thus it will be affecting of course this is a unique ecosystem. And then glaciers and ice caps, large masses of snow and ice on the land. These are actually glaciers and ice caps. They are large masses of snow and ice on the land. They serve as a fresh reservoirs for billion of the people. This is very important. So like we will see this one like Himalaya, which is also called third pole. And then we have ice sheets. This is massive continental sized glaciers such as Greenland and Antarctica. Okay. And they contain majority of the Earth's fresh water. Majority of the Earth's fresh water is actually locked in the continental sized glaciers, which in the form of ice sheets. Permafrost, permanently frozen ground in the Arctic and subarctic region. These are large amount of carbon which can be released as greenhouse gases when thawed. So this is actually like you can see the the ice is actually beneath the cover of the vegetation. So when if they are actually lost, it will release a huge amount of carbon dioxide and other greenhouses, methane from this one. So this becomes very important. Now the key air pollutants that are actually impacting the cryosphere, although there are many that will be affecting, almost all the pollutants will be impacting the cryosphere, but among the most important ones are actually like black carbon, and I have been talking about the black carbon. Then you have mineral dust and aerosols, and some of the important greenhouse gases like CO2 and CH4. So I have been giving the lectures about black carbon, and we know black carbon is a short-lived climate pollutant that absorbs the sunlight, warms the atmosphere, deposits on the snow, and its deposition on the snow can reduce the reflectivity or albedo, and this accelerate melting of the snow and ice. So this one sentence almost covered all the actually important impacts of the black carbon deposition on the snow and its impact. As we all know, so I hope that you are now aware that black carbon is a component of fine particulate matter, PM 2.5 or PM1 if you are talking about. So they are actually one of the most important component that is present of the particulate matter, and these are produced by incomplete combustion of fossil fuel, biomass burning and industrial activities. Okay. So we will discuss this one, how the deposition can impact these things. Then this is just remember this. So this means black carbon is component of PM 2.5. This means BC is particulate. Okay. And just remember, apart from dust and mineral aerosols, okay, and then there is another one I will be discussing about brown carbon, okay, dust and VRC. These are the three very important particulate species that are present in the atmosphere. So in the form of particulate. Others, the absorbing species, are short-lived or long-lived actually greenhouse gases. So I talked about the black carbon and dust actually, and brown carbon. We will discuss more details about the brown carbon in the coming slides. So you just remember that brown carbon is actually one of the is component of carbonaceous aerosols or light absorbing carbonaceous aerosols, which has absorptive properties lower than the black carbon but higher than the organic carbon. So it is in between the two. Okay, so dust actually a light absorbing, again this is again light absorbing aerosols. So if it is a light absorbing aerosols, it will warm the atmosphere. And the mineral dust also, what is that, are the type of atmospheric aerosols made of small particles of rocks that come from the desert or any other regions to glacier areas. Darkness, snow and ice contributes to the warming. So we will discuss in this coming slides that when they are deposited actually, so if you have kind of this snow, this is or snow cover here, and if you have deposition of black carbon plus dust plus brown carbon, what will happen? These are actually first of the things that they will do, they will contaminate this one, and because of the color of the black, this surface will look black, this will look blackish. Okay. And now what will do when the solar radiations falls on this surface S0, because if you have a pure snow is highly reflective, but now when you add pure snow plus black carbon plus dust or brown carbon, what will happen? These are called impurities actually in the snow because they are actually mostly present, but this when they are deposited, because they are absorbing, part of the solar radiation will be absorbed here. So when the solar radiation is absorbed by these particles and they will not be released immediately, when the so during daytime what will happen when we have sunlight, okay, and they will absorb this solar radiation and they will store. They will absorb and store. Okay. So they will absorb and store solar radiation, and once the surrounding becomes cool, they will release the heat. So what will happen when they release the heat? This surface will become melt. So this surface will start melting because they are now heating. Because of the heating, this surface will become, the temperature of the surface, snow surface will become higher, and this will start melting. So this is how these so if you have been asked, this is a very simple question and very important questions that is not only asked in the UG and PG, but as well as in the civil services exams, that how the black carbon or particulate pollutants are actually disturbing the glaciers and how they are actually accelerating the melting. So if imagine a situation that there were no black carbon and dust aerosols, the melting of the glaciers would have been there because of the presence of this long-lived greenhouse gases, but the melting will be accelerated because of these persons. So this is becoming very important. So the mechanism is here actually. Now lots of things can happen now. once it is deposited, you can imagine a situation that black carbon is deposited in between and there is snow in that one. So this surface will have less black carbon, that beneath the surface will have more black carbon, or it depends on the season. Some season when the snowing is there, other seasons when the snowing is not there, and then dust transport of these aerosols can be there. So in that one you can find these aerosols on the top of the surface. So during the snowing season, this black carbon and this light absorbing particulate species, they are absorbed, they will be within the glaciers or the snow sheets. But when during the what you call during the actually snowing season, so the top layer will have less particulate matter compared to the lower one. But in the other season when there is no snowing, what will happen? Transport of these pollutants will brought lots of pollutants and then they will be deposited on the surface. So when they are deposited on the surface, they will accelerate the melting. So in any way, because the surface, if the black carbon is absorbed here, sun radiation has to reach here, but here it will not be actually very effectively reaching, it will mostly accelerate. But when this top layer will be exposed, then the solar radiation will try to interact with this one. So first thing is actually like its melting depends on the season, and then as well as actually atmospheric temperature, okay, because during the summer season when the temperature, because of these greenhouse gases, they will lead to increase in the atmospheric temperature. So because of the temperature, although ice surfaces or snow surfaces, they will start melting, and you have additional source of melting, these light absorbing species. So this is why this becomes very important. Okay, so this is I talked about. I think I have explained much actually. Black carbon is emitted from this one, then settle down. So I think I have explained this in the very properly in this one. Just to remember this one in this slide. So this when S0 is there, this alpha will be there. This alpha will reduce because of the deposition of this one. So albedo will reduce. This is what is the main concept. So somehow or other you have to understand, and this is also deposition of this one. This is also called darkening effect. Okay, so this will also lead to an increase in the melting. So yeah, this is very important concept, and I think we have this is where actually that how they are actually released into the atmosphere, how these what are kind of different aerosols that are interacting with this one. So if you see here, I talked about the brown carbon, that directly they will affect snow surfaces, okay, brown carbon, and then you have a black carbon plus dust. So they will be directly affecting this one. Here the only probably the combustion sources are shown, and that's why you don't see these sources. But yes, these sources will be affecting this one, and you have direct effect of melting of the glaciers. So you can see these particles will be accumulated in the snow surfaces. Indirectly, they can actually lead to the cloud condensation nuclei. They can change their properties and then size of the droplets, deposition, reduction of the snow surfaces, and when they are deposited, they will lead to reduction in the albedo. So this is also called snow ice albedo effects or darkening effects, which lead to decrease in the albedo. So when you have a glacier surface, when they are deposited, this black carbon and these impurities are there, the alpha values will be lower, and this is what is happening, and which is called snow or ice albedo effects. So this becomes very prominent in this one, and directly you can visualize these things. Okay, so this becomes very important for us. Yeah, this is I have already explained why should we care about the black carbon. So because black carbon contributes to the global change or warming in the two ways. This absorbs the solar radiation around solar sunlight and heating air around it. Falling on snow or ice decreases reflectivity, okay, and then reflectivity or albedo, and thus increases the melting. So two way it has contributing, and black carbon absorbs heat 1,000,000 times more than carbon dioxide. This is actually more. So this is actually in terms of heating and in terms of melting potential, black carbon is more, has a more melting effect than the CO2 itself, and this contributes to the regional heating. This can disrupt rainfall patterns, reducing black carbon output could slow warming by 0.1 to 0.2%. This is very important statement. So even if we are all talking about the global warming, the temperature being increasing, if you just slow down or if you just remove the black carbon concentration or reduce the black carbon concentration in the atmosphere, the warming can be slowed down, and the reduction would actually prevent about 2.4 million premature deaths. I have not talked about this one, toxicity of the aerosols and then health impact. We will discuss this one. Particulate emissions from the diesel exhaust, major source of black carbon, are linked to the lungs, heart disease as well as cancer. So yeah, this we will be discussing this one. So this is one of the reasons that why should we care about the black carbon. So we have now understand that the black carbon actually will have increased snowpack heating. So this will lead to an enhancement in the solar absorption. The darkened snow absorbs more sunlight. I have explained this one, leading to localized heating. This is very important. This will be important for the localized heating. Whereas black carbon in the atmosphere, it will have a regional actually. This you have to understand. And then once they are deposited, it will actually lead to it will absorb more radiation. The heat raises the temperature of the snowpack, speeding up the melting and reducing the snow cover. Positive feedbacks. Exposures of underlying surface. As snow melts, underlying darkness surface, soil, rocks and vegetations are exposed, which further leads to a decrease in the albedo. So you have a positive feedback loop actually, and then amplified warming because of the lower albedo, heat absorption, amplifying the warming and accelerate further melting. So this is actually like positive feedback which leads to the increase in the atmospheric temperature and melting. Then secondary effects can be actually like changes in the snow grain size. If the black carbon particles are there during the precipitation itself, these black carbon particles can be actually accumulated with this one, or the precipitation, when precipitation start to happen, this black carbon can reduce the size actually, okay, radius of the snow, whatever the snow size was there. So snow grain size can be reduced actually. So pollution induced melting alters snow structures. This increases the grain size larger, and if you have larger grains, they scatter light less efficiently, and then further reduce the albedo. So this is the secondary effect or indirect effect you can say. And then acceleration of the snowpack stability, changes in the melting and refreezing cycle can be destabilized. Snow layer can destabilize the snow layer, potentially impacting ecosystem and hydrological system. So this is another very important thing. So I think I have covered in this lecture we have discussed the deposition of black carbon, or more specifically categorically if I talk about deposition of the light absorbing species, how they are going to affect your snow albedo, and how these particles, when they absorb the solar radiation and when they release the heat, they can actually lead to an increase in the melting of the glaciers. So these are the two positive, and increased in the snowpack heating leads to the positive feedback loop, means further increase in the melting and then amplifying the warming of the atmosphere. This can happen, and this is what actually we discussed in this lecture. So I think this is I stop here, and if you have any further questions, you can just write to me. We will discuss more in details. So take care, until then, bye bye.